Welcome back for the second half of lesson 1-4. So we're going to continue our conversation of solving equations, and we're going to continue with those same learning targets, working on solving equations and solving problems by writing equations. Today there's going to be a slight difference though. In the previous half, we were talking about solving an equation to get a numerical solution. Today we're going to talk about literal equations. What a literal equation means is an equation that uses two different letters for variables. So for example, P equals 4s. Okay, that would be an example of a literal equation because it has two different variables. All right, so what we're going to do today is we're going to talk about rearranging equations. We're going to be talking about solving an equation for one of the variables. So it'll still be an equation, but it's going to be reworked so it's solved for a particular variable. All right, so let's take a look at this first one. It says it wants us to solve the equation for k. So what that means is we want k by itself. So if you even want to write that, want k by itself. That's what that prompt means, solving it for k. And we're going to take two steps to do this. And it's actually in the same order as we solved equations. First, we're going to deal with addition and subtraction. Then we're going to deal with multiplication and division. So what I mean by that is to get the k by itself, the first thing I'm noticing is that term is having 2z subtracted from it. So we're going to focus on that subtraction first. So I'm going to add that 2z to the other side. Now I want you to notice the 2z can't combine with the 12, right? Those are not like terms. So don't be fooled and don't try to combine those together. Those stay separate. Okay, 12 plus 2z. So again, don't be fooled. Don't try to combine them. Those are not like terms. However, notice k is not by itself yet. So what I want you to notice, what to do next, is we still have to divide by that 6. Okay, so have to divide everything by 6. 12 divided by 6 is 2. 2 over 6. I do want you to reduce that fraction, okay? It'll be simpler. It'll be nicer looking if you reduce that 2/6 down to 1/3. Then we still have the z, so 1/3 z. Now we have an equation, a literal equation, that is solved for k, because we have the k by itself. Right, so that's ultimately the goal in rearranging these equations, is we want to get one of the variables by itself, the specified variable by itself. So let's take a look at this. The following equation relates temperature in degrees Fahrenheit and degrees Celsius. What is F in terms of C? So this is a prompt for the same thing. So if we want F in terms of C, what that means is we really want to get F by itself. So it's the same type of thing, just a slightly different sounding prompt. Now to get F by itself. Now there's two ways you could go about doing this. I'm going to show you what I consider the easiest way, okay? The way with the less steps. So we have that 5/9 sitting out front of our parentheses. So again, if we're undoing PEMDAS, that means that parentheses is actually going to be the last thing that we want to do, right? So we want to take care of that 5/9 first. Now, what's the best way to get rid of a fraction when you're dealing with multiplication? Well, remember that's one of the properties we already covered. Multiplicative inverse, reciprocal. So if we use the reciprocal, if we multiply both sides by the reciprocal, it's going to cancel off. All right, so that's going to be my first tip to you, is deal with that 5/9 first. And to get rid of it, you can use its reciprocal. All right, next, f is still not quite by itself. You're still subtracting 32 from it. So we're going to have to add 32 to both sides. And again, don't be fooled here. That 32 is not a like term with the 9/5 c, so you have to leave it separate. And there you have it. You now have f in terms of c. That means f by itself, you use c to calculate it. All right, what about this next one? The equation K equals C plus 273, release temperature in kelvins K and degrees Celsius C. And it has the same problem as the previous one. And in fact, it's a slightly easier problem than the last one. So we want C in terms of K. So we want C by itself. Okay, well, the only thing being done to C is actually adding 273 to it. So undoing addition, we use subtraction. Again, not like terms, don't try to combine them, leave them separate. In a much simpler problem than the one previous to it, you already have C by itself. It's already there, done. Now, in the practice work and on your test, there are going to be slightly more complicated problems, okay? So we could have one like this next one. AX minus BX equals C, and we want to solve it for X. Now, the tricky thing here is notice X presents itself twice in the equation. Okay, so that's a dilemma. That's something we haven't seen before. Okay, and so this is a unique case. X is there twice. Well, to solve for X, we need only one of them. Okay, and I can't just subtract them because I don't know A minus B. I can't just get a number there. So this is where you're going to factor. All right, this is a case you can factor out the X. So what does that look like? Well, factoring, remember, is the opposite of distributing. So it means I'm going to pull those X's back out front. So that's what you can do. If you have that variable in multiple terms, you can factor it back out. You can pull it back out because now there's only one thing left to do. Now to get X by itself, I can divide by that A minus B. And now X is by itself. So keep that in mind. A little bit trickier. However, something that I promise is going to keep showing up and is good practice for when we get into later chapters. Because we are going to end up factoring a lot come some later chapters. So let's practice this one. UV equals negative W minus TU, and we're solving it for U. Now this is another example where the U represents itself twice in the equation. But this time notice it's not in the same side of the equation. So that's a little bit of a problem for us. We need those U's together in order to factor them out, right? So I'm going to add this TU over. Okay, so I'm going to add it over. I need to get it with the other U. So I have UV plus TU equals negative W. Again, all I've done is I've added that TU to both sides, so I have those U's together. Now again, those aren't like terms. It's not the same variables, the same power, so don't go too far with this. All right. However, now I'm sitting where I was in the previous problem, aren't I? I have u's in both of those terms. So what can I do? I'm going to pull them both back out. I'm going to pull those u's out, factor them out. So now I only have one u left in my equation. And what's the only thing left to do now? Well, divide by that v plus t. Because now that'll give me the u by itself. Negative w divided by v plus t. And there is my equation. All right, so these later ones, again, a little bit of work. However, if you remember, just any term that has that variable, get to one side of the equation, factor it out, divide by whatever's left, you will get to the right answer. All right, so as always at the end of this video, I want you to take a couple minutes to write me a summary. Tell me about what we learned. Explain to me what you learned from this or something you're still curious about after watching this video.